The last chapter regards the normal distribution, and this is a distribution that I particularly like because it happens in so many different situations in life. And the example I'm giving here, although it's a very rough simplification, it links to you, and that's the reason why I mention it at all. You know that thousands of students take the Cambridge exams throughout the world. The results of these exams, let's focus on statistics 1. The results of the statistics 1 exam can be modeled by this normal distribution. And the normal distribution, maybe you already heard this before, is modeled by a curve that kind of looks like a bell and is therefore called a bell curve that has only two parameters. It has this peak value, which is the mean, the most likely value, okay? The mean value in this example for the results of the Cambridge Statistics 1 exams, okay? And then the other parameter that you will have is the standard deviation. And the interesting thing about the normal distribution is that no matter what situation you are studying, it always looks the same, in a sense that whatever the mean is, you will have 68% of the population in this sample will be to the left of one standard deviation away to the right of the mean, okay? Means that this area over here, from this point to the left, is always around 68%. If you are now going 2 standard deviations away from the mean, you will know that 95% of all the sample population is going to be over here, only 5% over there. And if you are 3 standard deviations away from the mean, always to the right, you will have 99.75% of the population, virtually all of it, to the left of this point, only 0.25 over there. This is true for whichever situation you are studying. That's why I find it so interesting. Don't forget that obviously the overall area of this curve has to be 1. Again, that's true for every situation. All right? So what does this mean over here? What is the area between the values A and B? For example, this one over here that I shaded in blue. This is going to correspond to the probability, in the example that I said before, that a grade is in between whatever A is and whatever B is. All right? What do we have to do then to calculate the probability that a particular student's grade is below a certain value V over here? What do we have to do to calculate the probability is below a certain value V? This is the only thing that you can do when you are studying the normal distribution. The only thing that you can do, no. This is the standard procedure, the only thing that you can calculate when you're studying the binomial distribution. Everything else comes from this basic calculation, as we are going to see. All right? So our idea, again, is to calculate the probability associated with this area that I shaded like this to the left of this value V. So let's see what the procedure is. First of all, how is this represented? Again, is the probability that X is smaller or equal to V. All right? So the first thing that we're going to do is to calculate the deviation from the mean, V minus the mean. Don't forget that you are going to be given the mean of this normal distribution. So you are just going to see how far away the value is from the mean. I didn't mention before, it almost goes without saying that obviously the mean divides the bell curve in 2 equal parts. If the whole area is 1, everything to the left of this is 0.5, everything to the right of this is 0.5, okay? So you know that V being a little bit to the right of the mean, this is going to be bigger than 0.5, right? The exact value is the purpose of what we are doing. First of all, then, calculate the difference, okay, between V and U, this over here, okay? But this is going to be, this value alone is going to be useless if not compared with the actual standard deviation. Don't forget that the standard deviation, actually the variance, but the value that is actually needed is the standard deviation, is the other element that is required for you to be able to study the situation at hand, okay? So what is the next step? You are going to see how many standard deviations away from the mean your value V is. How do you do that? You divide this distance, this difference, by the value of the standard deviation. So you can put this in terms of standard deviations, if that makes sense. All right? Basically, you are doing this. The difference divided by the standard deviation. In this case, this random example that I drawn over here, this V is slightly bigger than the standard deviation, so this would be 1.3. 1.3 standard deviations to the right of the mean. Okay? Then what do? You are going to use this number, which is called the z-value, and you are going to a table that you are always going to be given. And if you are doing exercises, you should have this in front of you. This comes in the MF 19, all right? This table over here, and you are going to find the probability associated with this z-value. Actually, it's explained here, all right? The z-value is this one over here, is already put in terms of standard deviations. That's why here on the median you have 0, all right? This is corresponding to the situation in which the distance over here is 0, right? Let me go back over there. If your V was the mean, then mean minus mean is 0 divided by the standard deviation, whatever it is. The result is 0, okay? So the z-value is going to correspond to the area to the left of it. It is shaded over here. It is represented by this Greek letter, which is phi of z. And every time you see this, it's time for you to go to that table and figure out what the probability is. The probability is inside this table over here. See all these numbers? These are all different possible probabilities. And now, how are you going to figure this out? Let's say, for the sake of argument, I don't think I put it here. No, I didn't use any specific number. But let's say that z is, the example I gave a little while ago, 1.3 standard deviations away. So 1.32, okay? 1.32. See this column over here? This is the main column. You have here the z. So 1.32, you have to look to 1.3 first, 1.3. So your probability, you know for sure, that is, let me highlight this, that is within this line over here. I don't know why you are not writing. I don't know what's going on. Okay, so the probability is in this line over here, corresponding to the z-value 1.3. But I told you it was 1.32. So which one of this is going to be? Look now over here, 1.32. So it is going to be this one over here, 0.9066. Let's say that you had more detail about the z-value. Let's say it was 1.324. 1.324. So 1.320, we already got there. But now the 4, what we are going to do with that? See here, add. Add what? Add 4. Go to the line in question, which is this one, and you have to add now 6. This is going to be on the last possible digit. So you have to add 6 over here to this 2. I'm going to put this bigger. You have to add 6. Maybe you weren't seeing. So 1.32, 1.32, and now add 1.32, and now 6. So this would be 0.9072. I added 6 over there. I added 6 over here. So this is going to be 0.9072. Make sense? Let me put it a little bit smaller. So again, start by looking over here for the z-value and continue constructing the number corresponding to the z-value first over here, and then adding whatever the last digit is by looking at this table. And you have here all different possibilities. You will have situations in which you need to get the value of the mean or the standard deviation, and you are given a probability. You have to work the other way around. You have to search for the probability that you are being given in the question over here, and then try to find yourself what the z-value is. So let's say that you have a probability of 0.8315. Okay, you look at find it over here, 0.8315. So what z-value corresponds to this? This is going to be 0.96. Okay, if it was 0.8318, then it will be 0.961, because I added 3 to this. All right, I'm just reversing the operation. So you're going to use that table a lot, this table a lot. Okay, get used to it. This is the way of calculating stuff using the normal distribution. Very important notes. Let's say that you are being asked to calculate the probability that x is bigger than a certain value, corresponding to this area over here. As I mentioned before, the only thing that you calculate is a probability that it is to the left. But you can do a very simple workaround, because you know that the overall area is 1. So you just calculate the probability that x is smaller than v, and then do 1 minus that. And you are left with the thing that you want, right? Let's say that v is smaller than u, okay? The only thing that you calculate, the z-value, needs to be bigger than the mean, all right? The z-value needs to be positive. If you look at the way it is calculated again, it is calculated by doing v minus u. So you assume that v is bigger than u. What if it is not? What if v is to the left of the mean? Then this table wouldn't be helpful, because, as it says, the z value has to be bigger than the mean. What do you do instead? Actually, this tells you what to do. You just do, again, 1 minus the probability of associated with the positive z-value. That's what I have here as well. If v is smaller than u, let's say that it is over here. You want this probability over here, but the table doesn't give you this. But you use the good thing, that one of the good things that you have about the normal distribution, which is that the shape is symmetrical. So this area over here is the same as this area over here. Would you agree? And how do you calculate that area over there? We already saw. It's 1 minus the probability of finding the associated with finding a z value corresponding to the left of this region over here. That's what we did over here. Okay, so the procedure is the same as above. If the z-value is negative, you just do 1 minus the probability associated with a corresponding positive z-value. All right, what else? What if you want to calculate the probability in between two values? Again, it's simple. Just calculate the probability of finding the associated with the value b minus the probability associated with the value a. You are doing all this area over here minus all this area over here, and you are left with the segment that you want. Okay, that's what you have over there. One last thing. You will have situations in which the thing that you are studying is discrete in nature. Everything that I mentioned above, I didn't say anything specific about that, but the variable was continuous. As you can see here, this is a line. It can take every single value over here on the x. But real life situations are often discrete. The example I gave is discrete. The grades that you get in Cambridge exams, it's whole numbers, right? So in this situation, you need to do an approximation that will turn this discrete variable into something more continuous. Let me show how this is done. This is called a continuity correction. So let's say that this is the range of all possible results that you have for a particular subject in CAIE. And let's say that you want to calculate the probability that the grade of a student is between 65 and 70%, a solid C. All right. And in order for us to turn these bars into a line, we need to do a continuity correction. And we will need more information. We will need to know if the limits that we are studying, namely the 65 and the 70, are inclusive. That is, if the 65 and the 70 are included as a possible grade, or exclusive, in which case they don't. We need to know that, and then what do? I zoomed in here, this section of the bar. And you can see here that the bars between 65 and 71, they are, as expected, something like this. All right? But if you want to turn this into something that is continuous, you have to look at the limits that go for each possible value. So, for example, the 66, this bar is limited by the 65.5 and the 66.5. The 67 is limited by the 66.5 and the 67.5, and so forth. All right? So what values are we actually going to use? For example, let's say that we want the probability that the grade is in between 65 and 70, including the values 65 and 70. So by looking over here, if you want to include this bar over here, that is not shaded, by the way, you have to use this limit of the bar over here, which is, I didn't write it down, but is a 64.5. And if you want to include the 70 as well, then the 70 must go until that limit, the right limit of the 70 bar, which is the 70.5. So the continuity correction in this case would correspond to 64.5 and 70.5. I'm going to use another example. Let's say now that you want to exclude both. If I want to exclude both, then I just need to go to the right-hand side of the 65 bar, okay, which is the 65.5, and I need to go to the left-hand side of the 70 bar, which is the 69.5. So that's what you have over here. And then you can have variations, and I'm just going to use the last one. Let's say that you want to include the 65 but exclude the 70. So again, this is going to be the 64.5 so that you include the 65, and it's going to be the 69.5 so that you exclude the 70. This is an important detail that you have to think of, particularly for the purpose of lesson 2.